will discuss one of the methods used in solving system of linear equations, which is called the elimination method. So the elimination method is a technique that allows us to solve two linear equations by eliminating one of the variables. So instead of solving both variables at the same time, we first remove one variable so that only one unknown remains. After finding its value, we substitute it back into one of the original equation to determine the remaining variable. So throughout this lesson, we will learn the basic concept of elimination, the step involved, and several examples that demonstrate how the method works. So, what is the elimination method? The elimination method is a strategy used to solve a system of two linear equations by adding or subtracting the equation so that one variable is cancelled or eliminated. So, these methods work best when the coefficient of one variable are already the same or can easily made the same by multiplying one or both equations. Once one variable has been eliminated, we solve the remaining equation to find the value of the remaining variable. So after that, we substitute the value into one of the original equations to determine the other variable. It is important to remember that after obtaining the solution, we must always check our answer by substituting both values into the original equation. So this confirms that our solution satisfies both equations. So in this lesson, we will study 3 work examples that progress from simple to more challenging situation. So, the elimination method follows 4 basic steps. The first step is line up. Arrange the equation so that the x terms, y terms, and the constant are aligned properly. So this makes the equation easier to compare and combine. The second step is match coefficient. If the coefficient of a variable are not equal or opposite, multiply one or both equations until they become suitable for elimination. The third step is add or subtract. So combine the equation by adding or subtracting them so that one variable disappears. The fourth and the final step is solve and substitute. Solve for the remaining variable, then substitute that value into one of the original equation to determine the other variable. And finally, verify the solution by checking both equations. So these 4 steps will guide us in solving every system using the elimination method. So we have here example. So let us solve the first example. The given equation are x plus y equals to 12, x minus y is equals to 2. Notice that the y term has opposite signs. Because of this, we can eliminate the variable y by simply adding the 2 equations. So, adding the equation gives us 2x equals to 14. Next, divide both sides by 2. This gives us x is equals to 7. Now that we know the value of our x, we substitute it into the first equation. So 7 plus y is equals to 12. Subtract 7 from both sides, therefore y is equals to 5. Our final solution is x is equals to 7 and y is equals to 5. To verify the answer, substitute this value into both original equations. So 7 plus 5 equals to 12, which is correct. 7 minus 5 equals to 2, which is also correct. Therefore, the solution is correct. Let's have another example. So the equations are 2x plus y equals to 13, x plus y is equals to 8. So observe that the coefficient of y are already the same. Therefore, we do not need to multiply either equation. So instead, we subtract the second equation from the first equation. So after subtracting, the y term cancel out. This leaves us with x is equals to 5. So next is substitute x x equals to 5 into the second equation. 5 plus y is equals to 8. Subtract 5 from both sides. Therefore, y is equals to 3. So the solution is x is equals to 5 and y equals to 3. So checking the solution confirms that both equations are satisfied. So this example shows that sometimes multiplication is unnecessary because the coefficients are already suitable for elimination. So let's have our example 3. So in this example, the equation are 4x plus 3y equals to 25. 3x plus 2y is equals to 18. So the coefficients are not the same. So we first choose which variable to eliminate. We will eliminate the variable y. To this, multiply the first equation by 2 and multiply the second equation by 3. So the new equation become 8x plus 6y is equals to 50. 9x plus 6y is equals to 54. Now, subtract the first equation from the second equation. So the y term cancel, leaving x is equals to 4. Next, we will substitute x is equals to 4 into the second original equation. So 3 times 4 plus 2, y is equals to 18. This becomes 12 plus 2, y is equals to 18. So subtract 12 from the both sides. 2y is equals to 6. And divide both sides by 2, therefore y is equals to 3. So our solution is x equals to 4 and y equals to 3. So finally, substitute these values into both original equation to verify that they satisfy each equation. So let's us now apply the elimination method to a real life situation. So a community fair sold 2 types of tickets. Ring toss tickets cost 50 pesos each. Dart throw tickets cost 70 pesos each. A total of 80 tickets were sold and the total revenue collected was 4,700 pesos. So we will let R represent the number of ring toss tickets sold. We will let D represent the number of dart throw tickets sold, and the first equation represents the total number of tickets. So R plus D is equals to 80. The second equation represents the total revenue. So 50R plus 70D is equals 4,700. So to eliminate R, we will multiply first the equation by 50. So this gives us 50R plus 50D is equals to 4,000. Now, subtract this equation from the revenue equation. So after subtraction, we obtain 20D equals 700. Divide both sides by 20, the value of D is 35. Next, substitute 35 into the first equation. R plus 35 is equals to 80. Subtract 35 from both sides, therefore R is equals to 45. This means that 45 ring toss tickets and 35 darts throw tickets were sold. So this example demonstrates how elimination can be applied to solve real-world problem involving unknown quantities. So let's have a quick recap to summarize in today's lesson. So the elimination method is used to solve systems of linear equation by eliminating one variable through addition or subtraction. When the coefficients are not suitable for elimination, multiply one or both equations first until the coefficient match or become opposite. Always follow the 4 steps. The first, line up the equation. Second, match the coefficient. Third, add or subtract to eliminate one variable. And fourth, solve for the remaining variable. Substitute to find the other variable and verify the solution. So remember that checking your answer is an essential step because it confirms that the solution satisfies both original equations. So with regular practice, the elimination method becomes faster and easier to apply. So that concludes our discussion on the elimination method for solving system of linear equations. So I hope this lesson helped you understand the concept, the procedure, and the application of the elimination method. So thank you for listening, and I hope you continue practicing solving equation of the linear equations using these methods.